Today we're going to be adding and subtracting rational expressions. Just like whenever you had to add 3 over 4 plus 5 over 6, you had to find a common denominator first. You had to find that the LCM of the denominators was 12, and we had to multiply the first fraction by 3 over 3, the second fraction by 2 over 2, and then you can multiply, and so you ended up with 9 twelfths plus 10 twelfths, and we had 19 twelfths as a result. We're going to go through the same process. So we're going to first find LCMs, and then we're going to multiply by that 1, because that's what that fraction is that we're multiplying by, which is the same on both sides to make the LCM. And they combine. And the last step is going to be look and see if we can reduce. So let's go ahead and go to the first thing, which is going to be finding the LCMs. So sometimes your LCMs will have no addition or subtraction, and so to find the LCM of these, let's first look at the numbers. So we need to find the LCM between 12 and 18. And so 12 is made up of 2 times 2 times 3, or can be rewritten as 2 squared times 3. 18 is made up of 2 times 2 times 3 times 3. And if you have troubles trying to get to the prime factorization, you can use that upside down division we used earlier this year. And so when you're finding the LCM, when you're looking at the numbers straight like this, you're going to look to see so first off, you need to have every number represented. So we had 2 times 3. And then you go to the exponents. Which exponent is the larger of the two? So the 2's were the matched, and have that as squared. Oh, excuse me. 18 is not 2 times 2 times 3. It's 2 times 3 times 3. And then your 3's exponent was 2. So the LCM of those two is 2 squared, which is 4, times 9, which is 36. Now let's look at the variables, and we're going to do the same idea. You're going to look to see which variable has the highest exponent. So for the x's, it's squared, and for the y's, it's cubed. And so we have x squared, y cubed. That's your LCM. So again, you're looking at find the prime factorization, and then you go to make sure every number that's in your prime factorization is represented, and go to your highest exponent. Same thing on your variable, everything represented, and go to the highest exponent. Now, sometimes you're going to have to factor first. And so let's take this, and when we have to factor, on today's lesson, I am not going to go through factoring each time and all the details. So reference back to this. We'll be using the box anytime it's a trinomial, or anytime that it's the A has an A and the C. If it's just the A and the B terms, then we'll factor by grouping, or factor out the GCF. So let's take this first one and factor it. And so for it, we have x squared times 1, so 1x squared. What multiplies to give me 1x squared? That will add to give me 2x. And it needs to be positive, so that's going to be 1x and 1x. And this is the x squared that came from the original. This is the 1. And this is the 1x, and this is the 1x. And so we have x and 1, x and 1. And so for the first one, we have the parenthesis of x plus 1 times x plus 1. Or x plus 1 squared. Now we're going to do the same thing, but we are going to use the second one. And so we're going to be using the x squared plus 5x plus 4, so that's going to give me x squared, 4x squared. So to multiply to give me 4x squared, that will add to give me 5. x, that's going to give me 1x and 4x. And this was the 4. And this is the x squared. So that gives me x and x, a 4 and a 1. And so for the second one, we have x plus 1 times x plus 4. So when I'm looking at my LCM, I need each of the factors represented. So I need the x plus 1 and the x plus 4. So what's in the parenthesis has to, on each side, be represented. So x plus 1, x plus 4. Now, if there's any of them that have an exponent on it, you're going to want to go with a larger exponent. So that's going to be squared. Now I want you to do the next problem on your own. So look at number 3 and find the LCM of those. You should have found 2, because I could factor out of both those first two, that first set, 2x plus 4. The x plus 2 is left behind, and that matched between the two of them. And then the x minus 3 was special to the second side. So when we're adding and subtracting, we're going to first find the LCM. So let's start off with finding LCM. And so our first one was x minus 1. And we're looking at for LCM of that, and x squared minus 3x plus 2. Here you would use that box. And when you get done with the box, you would end up with an x, and then a minus 2, and an x minus 1. And so my two factors would be x minus 2 and x minus 1. So what is in common between the two of them is this x minus 1. What's unique, and there's only one thing that's unique, is going to be that x minus 2. So now that we have our LCM, we are going to rewrite them. Oops, sorry, wrong color. And add the fractions because it says to add. So first off, I need to figure out what do I need to multiply each fraction to get to that LCM. So this one has the x minus 1, but is missing the x minus 2. So I need to multiply by x minus 2 over x minus 2. And then the addition just from the original problem. On the second one, we've already factored that denominator, so I'm going to write it as that factored denominator. And then the numerator, 2x plus 1. So we need to multiply and distribute the numerator because we need to combine like terms. And so we're going to multiplying out your numerator. So you may end up having to use a box and come in to create the numerator, or you may get to just distribute like this one. So we have x squared minus 2x is what that first numerator created. And then the denominator was just the 2 being multiplied. Leave your denominator factored. Plus 2x plus 1 over x minus 1 times x minus 2. So again, we're not multiplying that denominator back out. We're going to leave it factored all the way through this process. Now we're going to rewrite as one fraction. X squared minus 2x plus 2x. Oops, that's supposed to be a minus 1. I didn't catch that. Let's go back and fix that. That should be a minus 1 all the way down. And so you have x minus 1 times x minus 2. And combine like terms. we end up with x squared minus 1 over x minus 1 times x minus 2. So we're going to have to factor that numerator. And so when we're factoring, remember that's when we're using that box. When it's got the a and c, you're going to put the x squared and the negative 1, and you're going to try to figure out how you can create it to where they cancel out. These two terms cancel out and would multiply to give you a negative 1x squared. And so that numerator becomes x minus 1 times x plus 1 divided by x minus 1 times x minus 2. The like term that can cancel is here. X plus 1 divided by x minus 2 is your final product. And so the last part it asks for is find the restrictions. So on this, if we just have to add or subtract, your restrictions are going to come from your LCM. You're going to say each of these factors equal to 0. And so we have x minus 1 can't equal 0, and x minus 2, can't equal 0. And we're going to solve both of those sides. And so x can't equal positive 1, and x can't equal positive 2. So those are my two restrictions, and this is the combined answer. I want you to do, or we're going to do one more where we subtract. Same idea. Step 1 is find your LCM. And this time we have x squared minus 2x. And we have 2x minus 4. And so the common factor is an x on that first one. X minus 2 will be left behind. And the common factor on the second one is a 2, and x minus 2 will be left behind. So between these two, our common factor is x minus 2. And the other two things that we have that we need to account for is the x and the 2. So it's 2x minus 2, or 2x times x minus 2 is your LCM. So step 2 is going to be rewrite, and this time subtract. And so we have on that first one, x plus 2 divided by x times x minus 2. So what I'm missing is that 2 over 2. Minus, on the second one, when I rewrite it, I have 2 times x minus 2. What I'm missing is the x over x. And so I am going to distribute and combine in my numerator, leave my denominator factored out. And so that comes up with 2x plus 4 and so when we factor this, when we distribute on the second one, ends up becoming x squared plus 2x. And our denominators are going to be the combined version of this, but we want to make sure we leave it factored out. So 2x times x minus 2 and 2x times x minus 2. So when we rewrite the numerator, this is a little bit more challenging than with the addition. We have to think about that minus sign needing to be distributed. And you can do that all in one step, or if you want to start off with showing it in 2 steps, that's recommended. So So we're now going to distribute that minus sign to both pieces. And so that gives me 2x plus 4 minus x squared minus 2x, all divided by 2x times x minus 2. And then when I combine like terms, it ends up being x squared, negative x squared, plus 4 over 2x times x minus 2. So I need to factor that numerator, and I need to do it in multiple steps. Because the x squared is negative, I first need to factor out that as a negative 1, x squared minus 4. And then use the box to factor what's left. And when you do that, you end up with it being negative 1 times x minus 2, x plus 2, divided by 2x times x minus 2. And the term that's in common that can cancel out is that x minus 2, leaving you a negative in front, x plus 2 over 2x. So that's the simplified form. Another way they could have done it is they could have distributed that negative sign to both pieces in the numerator. Now let's look for our restrictions. And again, just like before when we were adding, you can go to your LCM. So 2x can't equal 0, and x minus 2 can't equal 0. So x is not equal to 0, and x is not equal to positive 2 are our two restrictions. So again, anything to make that denominator 0, and those are the things that would make the denominator 0. We're going to do two problems, one where you add and one where you subtract, next on the video. And then I will show you the worked out solutions. Oops, I'm going the wrong way. So number 6, you should have come up with x plus 2 divided by x, and the restrictions were x couldn't equal 0 or positive 1. On number 7 was x minus 2 over x minus 1, and the restrictions were it could not equal 2 or positive 1. Now becomes the compound fraction, and when we work the compound fraction, we're going to work the numerator, then work the denominator, and then divide. And so when we work our numerator, we have 1 over x plus x over y. And so our LCM, since there's just a single term in both of them, we can see that the LCM is going to be xy. It's what is in the denominator on each side. And so that first fraction, I need to rewrite and multiply by y over y. On the second fraction, I need to rewrite by multiplying by x over x. And so that gives us our numerator at the next step being y over xy plus x squared over xy. And so that combines to be y plus x squared over xy. Now let's work our denominator. The denominator is 1 over y plus 1. Well, another way of writing that 1 is 1 over 1. So our LCM is just going to be that y. So that means my second fraction needs to be multiplied by y over y. And so I have 1 over y plus y over y. And so we end up with 1 plus y divided by y. And so now we're going to divide. When we divide, we're going to rewrite it as a division outside of this. And so we're going to change this sign into the division sign. So it's our numerator, which we have already combined and found out that that is y plus x squared divided by xy divided by our denominator, which was 1 plus y over y. So when we divide, thinking back to our rules for division, we keep the first fraction, change the sign to multiplication, and reciprocate the second fraction. And so look to see what can cancel, and the y's can cancel out. There's no way to factor that numerator, and so we're left with y plus x squared over x times 1 plus y. And then you would set your restrictions to be everything in the denominator. You're really not going to have to do restrictions on your homework on these, but just realize that your xy can't equal 0. That means x can't equal 0. Y can't equal 0. 1 plus y can't equal 0. So that means y can't equal -1. And y can't equal 0. So those are your 3 restrictions. Now do number 9 and check your work with the video next. And so you should have come up with x squared y divided by y plus x, or x plus y, and your restrictions being x can't equal -y, or you could have written it as y can't equal -x. That's the same idea. And the x can't equal 0 and y can't equal 0.